As the global aviation community focused its attention on the Singapore Airshow, parameters disclosed in an ordinary-looking exhibition brochure caused a stir far exceeding the unveiling of new fighter jets. At the AVIC booth, beside the J-35, a stealth fighter model, a brief description of its powerplant stated it was equipped with two WS-19 engines, each delivering 11.3 to 11.8 tons of afterburner thrust. What did this figure signify? It signifies that a new top-tier contender has unexpectedly entered the realm of medium-thrust engine technology, long dominated by the West. This not only marks a milestone breakthrough for China's aviation engine industry, but could fundamentally reshape the power landscape for future medium stealth fighters and the associated balance of air power. Previously, based on remarks by WS-19 chief designer Huang Weina at the 2022 China Aviation Propulsion Technology Forum, industry estimates generally placed the engine's maximum thrust around 10 tons. Thus, the nearly 12-ton figure published in the Airshow journal came as a surprise to many professional analysts. This leap in thrust represents more than a simple numerical increase. It reflects intensive and substantial technological breakthroughs. The WS-19's success is largely attributed to breakthroughs in several key technologies. Among them, the application of ternary viscous fixed-length computational blade design technology significantly enhances the compressor's aerodynamic efficiency. This technology employs highly complex calculations to optimize the three-dimensional shape of the blades, minimizing flow losses within the compressor passages. Consequently, it achieves higher compression ratios and flow handling capabilities within the same physical dimensions. This effectively creates a more robust and efficient heart for the engine, laying the aerodynamic foundation for generating immense thrust. However, efficient aerodynamic design alone cannot guarantee stable engine output under extreme operating conditions. The WS-19's turbine inlet temperature, the temperature of combustion gases entering the turbine, is one of the core parameters determining thrust levels. Higher TGT implies greater thermal efficiency, yet imposes near-brutal demands on turbine blade materials and cooling technology. Public information indicates the WS-19 employs fourth-generation nickel-based high-temperature single-crystal alloy turbine blades manufactured using gas-cooled casting technology. This material inherently withstands astonishing temperatures, complemented by meticulously designed internal cooling channels that efficiently dissipate heat from the blade surfaces. Additionally, the engine incorporates thermal management designs like fuel absorption to further optimize the entire thermal cycle system's efficiency. It is precisely these dual breakthroughs in materials science and hot-end component cooling technology that enable the WS-19 to operate safely and reliably at higher temperatures, unleashing nearly 12 tons of powerful thrust. Placing this achievement in a global context reveals the historical significance of the WS-19's debut. For years, the advanced medium-thrust engine market has been dominated by American and European products. The US F414 engine series powers the F-18E, F Super Hornet and Saab Gripen fighter jets. Its latest variant reportedly achieves a maximum thrust of nearly 12 tons with a thrust-to-weight ratio of approximately 9.01. Europe's EJ200 engine powers the Eurofighter Typhoon, with its base model delivering approximately 9.2 tons of thrust and a thrust-to-weight ratio of about 9.2. Although the UK developed higher thrust derivatives like the EJ230-270 based on the EJ200 core engine, projected to reach 12 tons of thrust, with a thrust-to-weight ratio exceeding 10.7. Progress has been slow due to the lack of a clear application program. In contrast, the WS-19 propels itself into the top tier, alongside the latest F414 variants and deeply upgraded EJ200 models, boasting thrust approaching 12 tons and a thrust-to-weight ratio exceeding 10. Crucially, the WS-19 is not merely a paper concept or test bench technology demonstrator. It is an operational engine developed concurrently with the J-35 series stealth fighter and poised for mass production, endowing its technological breakthroughs with immediate and tangible strategic value. For the J-35 series fighter, the maturation and deployment of the WS-19 engine represent a complete transformation. As a twin-engine medium-sized fifth-generation stealth fighter, the J-35's performance ceiling is largely constrained by its powerplant. The twin WS-19 engines deliver a combined maximum thrust exceeding 22 metric tons, significantly enhancing the aircraft's thrust-to-weight ratio and delivering comprehensive performance gains. Specifically, this improved ratio translates to shorter takeoff roll distances, faster climb rates and acceleration capabilities, enhanced sustained maneuverability, and the potential for sustained supersonic cruise without relying on afterburners. Within the demanding carrier operations environment, this power advantage translates into greater takeoff weight margins and safer recovery capabilities. The carrier-based variants engines also feature enhanced corrosion resistance and bird strike protection reliability designs to withstand complex maritime combat conditions. For the land-based J-35A variant, this robust powerplant enables carrying heavier avionics or weapon loads, extending its air superiority in ground attack missions over greater distances. It effectively bridges the capability gap between existing heavy and light fighters, forming a highly complementary stealth combat system alongside aircraft like the J-20. From a broader perspective, the successful breakthrough of the WS-19 represents the culmination of decades of sustained investment and accumulation within China's aviation engine industry. It signifies China's gradual transition from a measure, copy, improve, follow-on model to an independent innovation phase grounded in robust theoretical foundations and a comprehensive R&D system. This capability development is systemic, encompassing all stages from fundamental materials research, precision machining processes, advanced aerodynamic design, digital simulation testing, to complete engine integration and validation. The technology, experience, and talent accumulated through the WS-19 project will not only directly drive its own continuous improvement and series development, but will also be applied to other aircraft engine models, and even broader power domains like gas turbines, creating a virtuous cycle of technological diffusion. Its emergence has completely shattered the technological barriers and market monopolies surrounding high-end medium thrust engines, enabling China to achieve a higher degree of self-reliance and control over critical subsystems in defense equipment. This holds irreplaceable strategic significance for safeguarding national defense security and supporting the independent development of aviation equipment. Looking ahead, the WS-19's deployment and application mark merely a new starting point. With the engine's mass production and delivery, the production capacity and service entry pace of the J-35 fighter are expected to receive robust support. Its outstanding performance parameters also leave ample room for subsequent deep enhancements. For instance, through further optimization of control logic, application of more heat-resistant materials, or introduction of adaptive cycle technologies, its thrust and fuel efficiency still hold potential for improvement. Moreover, the core engine technology of the WS-19 is likely to serve as the foundation for developing derivative engines for other applications, such as powering advanced unmanned combat aircraft or next-generation trainer aircraft. On the international market, an advanced medium-thrust engine that achieves world-class performance without any external usage restrictions will also open new horizons for China's aviation equipment exports, offering friendly nations more diverse and reliable options. That brief parameter listing at the Singapore Airshow, like a pebble tossed into a tranquil lake, has sent ripples spreading to every corner of the global aero propulsion landscape. The story of the WS-19 engine extends far beyond its nearly 12-ton thrust figure. It chronicles an industrial system overcoming formidable challenges to achieve breakthroughs, serving as a vivid microcosm of a nation's journey from catching up to keeping pace in critical core technologies. When the J-35 fighter jet, powered by this formidable Chinese heart, soars through the skies in the future, it will symbolize the new heights and boundless possibilities of China's aviation industry as it enters the realm of self-reliance. The roar of its engines not only heralds the birth of an advanced weapons system, but also signals the gradual dawn of a new era in global aviation propulsion.